Hello, welcome. Today you guys are going to learn about minerals. This is going to be a three-step process today. You're going to watch a video from study.com, which is going to be embedded right in this PlayPosit. You'll take notes from that video, so I'll have pauses embedded right into the video for you to take notes. Then you're going to have a hands-on portion where you actually play with some minerals and get a feel for all the different characteristics of those minerals. I think this is going to be review for most of you. We're going to talk about color, streak, hardness. So I think this is something you've probably experienced before. And then after that, there's a short reading. So the lab, when you're ready, you can come up and grab this sheet from me. It's a two-sided sheet. The first side is the lab portion, and then the second side is just a short reading. And once you're finished with this, you can hand in. I want you to do both sides and then hand it in. And when you hand it in, I will also check your note sheet to make sure that that's done, and that all three of those, the three steps will be included in your grade for today. Okay, so if you have any questions, just let me know. But when you're done with your notes, just come up and grab the minerals. All right, and I will get this video started.
Can you name some minerals off the top of your head? You likely came up with things like gold, silver, copper, and coal. These are all correct, but there are many more minerals on Earth, over 4,000 in fact. To understand what makes a mineral, we need to understand the basic requirements that categorize them as well as their properties. In order for something to be a mineral, it must first meet 4 criteria. First, all minerals are solid. So while water may contain minerals, water itself can't be a mineral because it's liquid. Minerals are all naturally formed. This means they can't be manufactured in a lab. Synthetic gems like cubic zirconia are therefore not minerals. All minerals have a unique and specific chemical composition. This is like the DNA of the mineral. It's what makes the mineral different from other minerals. Lastly, all minerals have a crystalline structure. Minerals are some of the most beautiful substances on Earth because they are always arranged in an orderly geometric pattern. Minerals of the same type always have the same geometric arrangement of their atoms. Minerals are classified by their chemical composition and crystal structure. These two features occur on a microscopic level, but we can see them in other ways because they determine a mineral's observable physical properties. In other words, what appears to us on the outside is determined by what's on the inside. The 7 physical properties of minerals are crystal form, hardness, fracture or cleavage, luster, color, streak, and density. Let's see how each one helps identify a mineral. Crystal form is the outward expression of the orderly arrangement of atoms inside the mineral. What you are seeing is the actual arrangement and structure of the atoms in that mineral. For example, look at some everyday table salt, which is a combination of sodium and chlorine. Normally what you see is a salt cube, but if you were to break this cube down into smaller parts, it would simply break into smaller and smaller cubes because that is how the atoms are arranged. Hardness is how resistant a mineral is to scratching, not how easily it breaks. Hardness depends on the bonds within the mineral, so the stronger the bonds, the harder the mineral. Mineral hardness is measured on the Mohs scale of hardness, which compares the hardness of different minerals. Diamond is considered the hardest mineral, so it's a 10 on the Mohs scale of hardness. Talc has a very weak bonds between its atoms, and so it's a 1 on the Mohs scale of hardness. If it helps, you can think of the hardness of talc in relation to the hardness of your fingernail, which is about a 2.5. Fracture and cleavage describe how a mineral breaks. Some minerals break very nicely along smooth planes, and this is called cleavage. Minerals that break this way do so because their atoms are arranged so that they break apart from each other along these planes. Mica is an example of a mineral that has cleavage. If a mineral fractures, it breaks in uneven ways that are not flat or parallel. Again, these minerals break like this because that's how their atoms are arranged. Luster is how reflective a mineral is. Minerals are usually either classified as having metallic luster, which is very shiny or reflective, or non-metallic luster, which is not shiny and is very dull. Some minerals can be identified by their color, but some minerals such as quartz come in many colors. Streak is often a better way to identify a mineral, which is the color that shows up when a mineral is scraped across an unglazed porcelain plate. However, minerals with non-metallic luster all have a white streak, so this is really only helpful for minerals with a metallic luster. Finally, the density is how tightly packed the material of the mineral is. Minerals that are more dense have more tightly packed atoms than those that are less dense. Minerals are in just about everything. That computer you're using is full of them. Do you have any jewelry? All of those stones and the gold or silver that they are made of are minerals. The copper wiring in your house, the aluminum foil in your kitchen drawer, the nails holding your pictures on the wall? Yep, those are all minerals. Precious stones and gemstones are things that you are likely quite familiar with. They are rubies, diamonds, emeralds, and the like. Metals like gold, silver, copper, lead, iron, zinc, and aluminum are extracted from ore, and the process of extracting these minerals is called metallurgy. Fossil fuels like coal and petroleum are also minerals that you're probably quite familiar with. These power our cars and heat our homes. Minerals are inorganic compounds that are classified by their physical properties. The physical properties of minerals define their unique features such as color, luster, and density. While minerals do have unique properties, they must all be solid, naturally formed, have a unique chemical composition, and have a crystalline structure. Minerals are not evenly distributed across Earth, nor are they shared equally once they have been extracted from the ground. Because so many types of minerals are important in our everyday lives, they are in high demand and can cause conflict between those who can afford them and those who can't.